Okay, so today we'll continue our discussion of concurrency available in WCF service. And first of all, we'll recap what we have learned so far. Let me share my screen. Okay, is my slide visible? Okay. So let me reshare the screen. Okay, now I think it is visible, right? Okay. So in WCF service, two concepts are important. Instancy, how many instances you want to create. So we have seen per call. So that means for every request from the client, a new service instance will be created. Then we have per session. That means for the same client, same proxy object, if all the requests, the same service instance will serve all the requests coming from the same client, same service, same proxy object. And third one is single. Single means nothing but singleton. Okay, so this is required that for all the clients there is only one service instance. Okay. Now we do also have the concurrency mode. That means for each instance, do we allow the multi-threading to be possible on the service side to increase the throughput? So if we go for the single, that means we do not require the multi-threading on the service side. Okay. In that case, for every instance, there is a single thread only. And these are the two most important concurrency mode, single and multiple. Multiple means the same service instance can be run by concurrent threads to increase the throughput of the overall system. But in that case, we have to maintain the synchronization issue. Okay, we have to handle the synchronization issue ourselves, because if the service is running and it might be maintaining some state, okay, it might be. So for example, some common data structure is there, right? Suppose there is a data structure called linked list, okay, and we have this linked list. Okay, it is been maintained by this service instance. If multiple threads are using this data structure, then there is a possibility of synchronization issue, right? So if there are thread T1, thread T2, thread T3, then there is a and the context switch can occur at any point in time. So this data structure should be handled properly or one at a time. So we should make it as a part of the critical region. Okay, we are using critical region, or we can use the various constructs like monitor, semaphore, read write lock. Okay, various read write locks are available. So this kind of synchronization constructs are available that can be used to make this safe from the different threads access. Okay, so if multiple threads are accessing some state of the system, then we have to use this synchronization constructs, right? And finally, we have the re-enter. It should be used only if we are the service is calling back the client. So if we have client and this is the service, if the client issues some request and the service callbacks the client, and now the client may send the reply back to the service. So if there is a one-way callback, then it is no issue. But if the client is also sending the reply back to the service, at that time there is a possibility of some synchronization issue, because some another thread is already accessing it. Okay, suppose this is T1 and T2 has acquired this. If T2 has acquired a lock on this service instance object, then this callback won't be able to enter the, or it cannot access the this service instance object. Okay, so suppose this is executed by thread 1. Okay, this is the initial call from client to service. So we call it as a thread 1. It is executed by thread 1. Now there is a callback from service to client. At that time, this thread 1 will release the lock on this object, because now it is no more accessing the service object. Now after that callback will be executed over on the client side, then it will send the reply back to the service. At that time, it may again try to access the said this service instance. And meanwhile, if another thread has already accessed this, then this is not allowed. And if suppose it is even there is no thread, then this callback will require re-entered mode to be on. So this is a special case for a callback kind of call only. Otherwise, normally either we are using single or multiple. So most of the time we are using these two only. This is a special case only for the callback calls. Okay, so in WCF service it supports callback call. Otherwise, normal all other web services do not support this callback. So it is not standardized, in fact. So there is no WS standard for callbacks. It is available for only the WCF within the .NET framework. This callback are supported. For other standard web services, it has not been standardized, so we cannot use it. And now, depending upon this combination, we will have different type of combination and the different behavior that we might achieve. So we'll go through this. We already seen this. We have the client. This is the per call instancing and single concurrency mode. So see that for every client, there is a new service instance, because it is per call. That for every request, a new service instance will be created. Okay. And here we'll see that due to the single, in fact, single means only one thread. So one thread should handle this request. So basically, it will be only single thread will be created. Again, we'll see the this we already discussed, but we'll again look at the demo application through which we will discuss this output. So first we'll create this WCF service. Okay, there is only one method, one operation, hello, and this hello will send the client names. Client application will send its name to the service. Okay, so this is a simple call, something like this. This is client and this is service, and this is, sorry, this will invoke this operation hello along with the name, client name. On the service side, and you will see that it is one way. Okay, one way is equal to true, so it is not sending back the reply back to the client. What is our implementation? On the service side, we are maintaining this counter. Okay, we are maintaining this counter variable. We increment the counter and display the client name. Okay, what we have received. Okay, sorry, screen not visible. Okay. Now it is visible. Okay, so you can see that what we are discussing. There is a one-way call from client to service, hello, and we are passing the name of the client. On the service side, we are implementing, we are displaying the client name, then the current value of count, and the thread ID. Okay, so see that if you are using multiple concurrency mode, okay, multiple threads will try to access this, or they may try to run this code. So at that time, the same this hello function might be executed by multiple threads. Okay, so in that case, thread ID we are displaying. Okay, manage thread ID and current date and time. Okay, current date and time, and we add some delay of 5 seconds. Okay, and we'll again increment if the same client is requesting or receiving the hello request again, then this count will be incremented. So this is a local variable to that service instance. So this count will get the new value of count. So we'll begin with this first per call single. So we have in fact 9 combination. So we begin with the first combination per call single. So for every client request, new service instance will be created. If there is another request, new service instance will be created. Okay. So this is per call. That is the behavior of per call. And what do you mean by single? Concurrency mode single. This is single thread for the entire, see that the request is coming from the same client. So for the same client, there is only one thread. Okay, that is the single. Because here on the service side, for the same proxy object, all the call from the same proxy object, there is a, because it is called context. Okay, that's why you will see that instance context. Okay, here this is called, this I have drawn a frame which is called context, service context. So there is a single service context, and for the entire service context there is a single thread. Okay, so only one thread will handle all the requests. So that is the meaning of concurrency mode and instance context mode. Is it clear now, this combination per call single? Then we will have per call multiple. Second combination will be per call multiple. So instead of a single thread, we will have separate thread. For each service instance, we will have multiple threads, or multiple thread can access the same service instance. Okay. Reentrant will be useful only if we are doing callback, but still we will use the reentrant for the sake of completeness. So now basically this is the service is ready. Now we will have the host. So there are either we can use the Windows form based application, or you can use the console application for the host. Okay, and we'll see the benefit and drawback of using these two hosts. As such, there is no difference, but we'll see that there is some issue in the Windows form based application. Okay, there are some issue while we host it on the Windows form based application. So this is a host. All of you have seen this, how to create the host. And now we'll see that this is the, we are creating service host instance. Okay, we are creating service host instance within this Windows form based application. So there you will see that for any Windows form based application, there is a single UI thread. Okay, there is only one UI thread. there is a single UI thread, and this service host will run inside this UI thread. Okay, the service host instance. Okay, we are creating this service host instance here. Okay, so this instance is running inside this single UI thread. So it will create problem if we set the concurrency mode to multiple. Okay, it will create a issue when we use the multiple concurrency mode. So here you can see I have written a comment, and I will also provide you the more resource about this problem. This is the issue with the Windows form based application where all the messages are queued up, and then one message will be handled at a time. So this you must have faced, like you are opening some say browser application, and then you are opening a tab, and within a tab, if it is not sometime if it takes some time, then there is a message that yeah, the browser window is not responding. Should we close it or wait? Have you seen this message or not? Just a minute. Okay. So so here I have written that when services are hosted in the Windows application, so they will be running inside the UI thread, and it act as a throttle because it can process the message one at a time, so that we cannot use the multiple concurrency mode. And even if we use it, it will not be creating multiple thread. Okay, it will act as a uh, single thread. Rather, the messages will be handled one at a time because uh, all these events are created and all the messages are queued up. All the messages are queued up. So suppose on the GUI, suppose there are three buttons. Okay, on the GUI there are three buttons: button 1, 2, and 3. So if I click on this button, then I click on this button, and suppose it takes more processing on this button invocation, then here it cannot, all this processing will be queued up. Okay, all the processing of B1, B2, B3 will be queued up. So they will be executed one after another. And if it takes long time to handle this button one handler, then the remaining handler will not be executed. And that's why you sometime if it takes longer, then GUI cannot be refreshed because it is UI thread, and single UI thread can do one thing at a time. So it cannot refresh the screen, and that's why you will see this message. Have you seen these kind of messages for other Windows based application also? Yes or no? So this is the problem, and we'll see how to solve this. So there is a simple solution to it. Either you go for the console based application where there is no UI thread. Okay, so then the problem can be easily solved by hosting your web service on the console based application. Okay, And if you want to still use the Windows Form-based application, then uh, create this service host instance in a separate thread. So that is the second solution. So one solution is very simple: go for the console host. Second is you create the service host instance in a separate thread. So create a new thread for hosting your service, right? So we'll see both the solution. Now we'll create the client. Client design is very simple. Here we write down the client name. Okay, and we press the button. So this will be passed as the parameter to this hello invocation. This will be go to the sorry. This will go to the service, and on the service side it will be executed. It will display the value of count and the client name and the current date and time and the thread ID. Okay. Now for every button click, what we do, we call the hello 5 times. Okay. We call the hello method 5 times. Okay. We are iterating through 5 times, and we are sending the same name 5 times actually. So basically we are calling it 5 times. Now we run the host. So service is ready to accept the request from the client. Now we run the client, and we write down the name of the client to be the first client. We will see the output. What we have done, we have set the concurrency mode to single and instance mode to per call. So for per call, a new instance will be created. And there is service instance. But now there is only one call, one service instance. Okay, hello. This is for first time. For the second time, hello will be invoked. New service instance will be created. Third time, then we will have S4 and S5. Okay, 5 service instances. And every time we'll see that the count value is local to the every service instance. Okay, so that's why we'll see that count value is 1. And we get the same client name because all the requests are coming from the same client. But now we'll see that concurrency mode single means only one thread. Okay, so for the entire context, we call it as a service context. So there is a same thread. We'll see the thread ID is same. And we also see the time, date and time. Now we'll see that there is a 5-second delay between each call. The reason is same thread is serving the request. Okay, so it will become like a sequential execution. Instead of multiple threads are running at the same time, it will act as a sequential execution. Okay, so we should not actually this combination we should not use because we are not getting the benefit of concurrent execution. Okay, so we'll see that there is a 5-second delay between each call. Okay, so you can see that this is per call single. Okay, so for the entire service context, this we call as a service context. We are getting a single thread. Okay, single thread is allocated. So if thread is executing the first one, then the second, all the remaining calls will be queued up. Okay, all the remaining calls from the same client on the same proxy object, they will be queued up and they are waiting to run. So now this thread one, whatever the thread number, will be allocated for the second call, then third call, fourth, and so forth. So it will be like a sequential execution. I hope that this is clear. per call single. Okay. Then, okay, we also try this drastically. We try to check that multiple is working or not. So that's why I have just changed it to multiple, per session multiple. And multiple is useful only if it is per session. Otherwise, see that for every, if there are single thread for individual thread for different instance, doesn't increase the throughput. For the same session, if multiple threads are there, then it will increase the throughput. So we try with the concurrency mode multiple with the per session combination. Okay, so let us check that. And what you have to do, you have to rebuild the entire solution. Okay, you have to rebuild the entire solution because now we are modifying the service. Okay, so if the service is modified, it will affect the host. Okay, and then there is no need to change the client. Okay, there is no need to change the client. Okay, if you are updating host, then this DLL file will change. It will affect host. Here, DLL file will change. It will affect the host. And then the service reference, we have to change the service reference. So there are two options for updating the service reference. You can right click the service reference, and then there is a option for updating service reference. So I think in the Visual Studio, within the connection, within the Solution Explorer, there is a connection. There you go to identify your service reference and update it. Okay, you identify your service reference and then you need to update it. So in fact, if you just rebuild the entire solution, it will serve the job. Otherwise, you have to do it manually. Now we are using this another client. We give the name second client. So see that even though we are using multiple thread, but threads are single only. Okay, multiple threads are not created. Okay, multiple threads are not created. The reason is I told you that it is UI. Our service host instance is running inside the UI thread, and UI thread is only one. Okay, there is a single UI thread, and that's why all the requests will be queued up. Okay, all the requests would be queued up. So at a time only, it will act as a sequential execution. So you can see that 5-second delay. Instead of concurrent execution, you get the sequential execution. So to solve this problem, one solution is to use the console application instead of the Windows form application. This is the first solution. Now there is no UI thread, and the service host instance can be executed concurrently by multiple threads. So that is possible. Now we are running this under client. The client name is client 2. So this is a client 2. For client 2, we'll see that what is the value of count. We'll see that again. Let me draw same client, client 2. It will call this service instance 5 times. So this is per session. Okay, so same service instance will be there. Okay, no service instance will be created. Same service instance will handle all the requests. So if we have the first call hello, then second is also the hello, third, fourth, and fifth. All the calls are to the same service instance, and we have common count variable. Okay, initialize to 0, and then it will be incremented for every call. So we get the value of count to be 1, 2, 3, 4, 5. Okay, because now the same variable is incremented. So it will be 1, 2, 3, 4, 5. But now see that multiple threads. So instead of a single thread, if it had been single thread, then it will be sequential execution. But here, due to the multiple thread, concurrent execution is possible. And if you are using concurrent execution, you can see that all the threads are running almost simultaneously. Okay, all the threads are started almost simultaneously. So it is not the sequential execution, and you get the better throughput. Okay, you get the better throughput. Is it clear? This combination per session multiple, just host it on the console based application. Any doubt in this? Okay, so no questions. Again, we try it out for the another client, and we'll see that new threads are created and they are also running concurrently. Just look at the second part. Okay, number of seconds almost same. At the same time, all the 5 threads are created. Okay, because it is multiple, so multiple threads will be created and all the threads are accessing the same service instance. And also you can see the value of count. Okay, because these are the same count variable which has been accessed. So what we do, this threading issue can be easily handled in the Windows form based application if you are creating or creating the service host instance in a separate thread. Okay, so we create a new thread and this is the function that will be executed, and within that so here we start this thread, and this function basically will have the code for creating the service host. Okay, so we create the new service host instance, add the service endpoint, add the metadata behavior, and finally uh, service host open. Okay, it will be ready to receive the request from the client. And now once again we run it, we get that per session multiple. So we'll see that new threads are created and they are almost at the same time. You can see that they are almost at the same time, and because it is per session, that's why this count are incremented by 1. Okay, we do not have the same count value. This is the once again we are trying per calls single, and these are the things per call single. So for a separate, it is per call. So for every client, there are 5 times 5 service instance will be there, and count is 1. Okay, count value is 1. It is per call. Okay, and it is single. That's why the thread ID is same, and it act as a sequential execution. You can see that 5-second delay between each execution of each invocation. So it act as a sequential. Per call multiple, again, now the only difference is it will allow the multiple threads to run. So for every call, even though we may have, so see that for every instance the count will remain 1 because there is a separate counter variable. Okay, local variable. So the count value is 1, but now multiple threads can run this. Okay, so you can see the multiple threads are there, and every time you run you will get the different thread ID and the ordering might be different, but almost they are running concurrently. You can see the start time. Okay, this is the start time. They are not waiting for other thread to finish. So it is per call multiple. Okay, multiple threads can run it. per call reentrant, though we are using it. Actually, this is useful only if we are using the callback, but still we are running it. So for per call, you can see the count value is 1, but it acts as a, see that multiple threads are created. And again, they are concurrently running. But this is useful only if the service is calling back the client. Okay, if the service is calling back the client and it is executing some function on the client side, and it might also return the reply to the service. At that time, whether it will be blocked or not, that will be decided by reentrant. If reentrant is not there, here it will be blocked. Per session single, so we are using single thread. Actually, that will decrease the throughput, because for the same session, if multiple threads are not created, if you are using multiple threads are not created, same thread will serve all the requests. Okay, even though it is per session. So you can see that per session it is single. So within the same session, 5 hellos are there. So they are referring to the same count variable. Okay, the same. Sorry. This is the client. This is the service. Hello 5 times. Right. So within the same session, so that's why we get the different values of count. But it is single. Okay, concurrency mode single. So thread is only one. Okay, same thread will be assigned. Yeah. So that we get the sequential execution. Okay, so you can see the 5-second delay between each call. So it will be sequential execution. Okay. So all this will be executed one after another. Once H1 finishes, then H2 call, second hello will be executed, then third hello, fourth hello, fifth hello, and so forth. Per session multiple is useful because it will increase the throughput. Within the same session, you will see that multiple threads are created and they are running concurrently. So the job can be run in lesser time. Okay. And again, it is per session. That's why these count values are 1 to 5. Per session reentrant, this is similar to per session multiple. It is per session and multiple threads are there, but right now they are concurrently running. They are concurrently running. Now single and singleton. Okay, singleton and single thread. Okay, so this is the very restrictive mode, because now there is single service serving all the clients with the single thread. Okay, so again, just for sake of completeness, I have written it, but otherwise we should not use it. It is so much restrictive that it will at a time only one client request would be served, something like that. So suppose I am trying with two client. Okay, client 1 and client 2. Okay, this is the first client, this is the second client, and I click on button 1. So click on button 1 and after button 2. Okay, so first request is from this and then second request from this second client. So it is 5, because see that the value of count, because there is only one service instance, they are incremented by 1. So even though there are two clients, these are from the first client and these are from the second client. So the count values are incremented by, it's a common variable, but it is single. That's why the same thread is there. Okay, single thread will serve all the requests. So it is quite restrictive and they are executed concurrently because one after another. There is a 5-second delay. Now, if we allow the multiple thread, what will happen? Once again, the first client, second client, request from second client. This is the it is singleton. So there is a single instance, but multiple threads. So multiple are allowed. Okay, multiple threads are allowed, and you can see they are running concurrently. They are running almost concurrently. Okay, single and reentrant. So there is a single instance and reentrant. So it will act as a multiple threads. Because it is a single thread, counts are incremented by one and they are concurrently executed. Okay, fine. So this is, we have tried out all the different combination. We have tried single, multiple, and single reentrant. So all the 9 combinations, and we have seen the corresponding concurrency, how whether they are creating multiple threads or not, whether it will increase throughput or decrease throughput, that will be determined by this combination. So I hope that this is clear. In application, you have to, when you are changing this mode, you have to rebuild the entire solution. That will automatically update the reference, as well as the service reference will automatically update it. So in the newer version, it is automatically updating, but in the, I think in the older versions of the Visual Studio, I had to update it manually. So if you follow this slides, you might see that I am manually updating the service reference. But I also tried it with the newer version of Visual Studio. There, if you simply rebuild the solution, it will automatically update the service reference. It will also automatically refer the new DLL file. So if I am recompiling my service, okay, if I recompile the service, new DLL will be created, and this DLL file is referred in the host. Okay, so first of all, you need to stop the host. Okay, you have to stop the host. If you don't stop the host, even though you might have created, you have recompiled the service, it might refer to the old DLL. Okay, because this host is accessing this DLL file, which is inside the memory, which is the older DLL. In the file system, it might have generated the newer DLL. So remember that when you are trying this experiment, make sure that you first stop the host and rerun the host after compiling the service. After changing this instancing and concurrency mode, you have to recompile, save. First of all, save, then recompile. So new DLL file will be produced. Okay, and then you have to stop the host and rerun the host. Okay, rerun the host. Then you have to update the service reference. Okay, then you have to update the service reference in the client. So if I have, let me check on the if I have it is, I will show you that how to update. So let me. Okay, so you can see that in this client app, I am there is a service reference. You right click and just okay. You just expand these service references Then this is the service reference one. You right click and then in the context menu, there is an option of update service reference. So if there are any changes in your endpoint on the host, then you need to update the service reference. Then it will automatically update the app.config file on your behalf. This app.config file will be automatically updated to reflect any change in the on the host side. If there are any changes in the endpoint, you are adding max endpoint or you are adding any further business endpoint, then you should update it. Okay, you should update it by right clicking the service reference, and there is an option of update service reference. If you are removing endpoint, then also you need to update it. So there are two ways: either you completely delete the service reference and then you again add service reference, or there is a better option of right clicking and update service reference. Okay, fine. Any doubts so far? Okay, fine. If there are no doubts, you can ask any question or any other doubts you are facing while implementing these programs. I already uploaded the lecture slides onto the Google Classroom. So I think now most of the WCF service related concepts are covered, and then you should be able to complete your project. Okay, so using this WCF service, you create your project, you can design your client, whether you might have selected the web client or you might have selected the Windows Form based client. So now you should be able to complete your project. So you will have enough time before third sessional to finish your project. So after third sessional, we will have the project submission. Any doubt related with the lab or your project? Anything else you want to discuss? You can discuss right now. After third sessional. Because already now you have learned the main concepts. So right now we are not expecting a complete project here. Our expectation is to you write down or you break it down your project definition into web services, and those web services you can access it via the client. So right now we are going for only .NET client. because this some of them are not interoperable. Some of the binding are not interoperable. For testing purpose, we are going for this, and it is SOAP based. But nowadays, RESTful is much popular. So if you are writing any client in other language which uses SOAP based service there, then it is possible. Suppose you can develop the Java client which can access your SOAP based web service. So that is possible. If you are using WS HTTP binding, then it will be interoperable. And then instead of the .NET client, you can also go for the Java client or any other uh, client written in any other language. Okay, fine. So we'll conclude today's session.